Spin is one of the most powerful tools in table tennis. It creates deviations in the ball's trajectory, causes unpredictable bounces, and makes it more difficult for the opponent to return shots. In this video we will go over the key factors for generating the maximum spin. When we hit the ball, the energy from the impact is transferred as linear speed and rotational speed. Linear speed refers to how fast the ball moves in a specific direction, while rotational speed describes how fast the ball rotates around its own axis. Depending on the type of contact we make with the ball, we will transfer a greater or lesser proportion of linear speed and rotational speed. In table tennis, we can mainly distinguish between two types of contact: flat contact and friction contact. Flat contact occurs when the force is applied directly toward the center of the ball, transferring almost all the energy as linear speed. This makes the ball travel quickly but with little or no spin. On the other hand, in friction contact, the force is not directed toward the center of the ball but rather brushes against it, generating torque and transferring less linear speed and more rotational speed. The farther the force is applied from the center and the closer it is to being tangential or parallel to the ball's surface, the less linear speed and the more rotational speed will be imparted. So, depending on the type of contact we make with the ball, we will transfer a greater or lesser proportion of rotational speed, and to generate the maximum rotational speed, and therefore the maximum spin, we need to create friction contact, where the force applied is as parallel as possible to the surface of the ball. However, this force should not be completely parallel, as the ball needs to sink into the rubber enough to ensure proper grip. This is where the components of the racket come into play and how they interact with the ball. The racket consists of three key components. The rubber. This is the outer layer and has a high coefficient of friction, allowing the ball to grip its surface and gain spin. The higher the rubber's friction capacity, the more spin it can generate. The sponge is the middle layer, which allows the rubber to deform more upon impact, increasing the contact time and enhancing the transfer of spin. The thicker the sponge, the more friction the rubber can exert on the ball, resulting in greater spin generation. And finally, the wood. This is the core of the racket, the most rigid layer, which creates a harder and faster rebound when interacting with the ball, minimizing its interaction with the rubber. If the ball makes too much contact with the wood, the shot becomes faster, increasing linear speed, but at the cost of losing friction with the rubber, which reduces the amount of spin generated. To generate the maximum spin, the ball should interact as much as possible with the rubber and sponge, while minimizing contact with the wood. The ball shouldn't make excessive contact with the wood but must apply enough pressure to compress the rubber and sponge, ensuring a better grip. That's why we need to create friction contact, applying a force that is almost tangential but not entirely. The ball must sink slightly into the racket so the rubber can grip it better and transfer more spin. Besides the type of contact we make with the ball, if we want to generate the maximum spin, we also need to consider the power or speed of the stroke. The speed at which we hit the ball determines how much energy we transfer to it. The higher the stroke speed, the more energy is imparted to the ball. And when executing a good friction contact, this additional energy results in a higher rotational speed. So, to increase spin, we need to increase stroke speed. This can be achieved by moving the racket faster, but also by taking advantage of the incoming movement of the ball. For example, when executing a push shot, we can use the ball's upward motion after the bounce to brush it with greater speed, thereby generating more spin. However, more speed doesn't always mean more spin. Increasing speed often comes at the cost of control, and control is essential for achieving good friction contact. If the stroke speed is too high, the lack of control will make it harder to create proper friction contact, reducing the amount of spin transferred to the ball. That's why generating more spin isn't just about maximizing power, it's about finding the right balance between power and control. You need to identify the maximum speed you can generate without compromising control or the quality of the friction contact. Through technical development, psychological tools, and specific training methods, you can improve control and power to enhance your ability to generate spin. We explore this in more detail inside our academy. In summary, to generate maximum spin, we need to combine good friction contact with a high stroke speed. The force applied should be as tangential as possible, while ensuring that the ball applies enough pressure on the rubber and sponge to maximize grip. Increasing stroke speed will enhance spin, but only if the quality of the contact is not compromised. Mastering these aspects will allow you to generate more spin in your shots, making them more effective and harder to return.